vertex form again, day 4. So we start out with the equation f of x equals x minus h squared plus k. When I'm trying to get a vertex, h comma k, h is the opposite sign that it looks like because the negative belongs to the equation. So h is 3, k is 1, vertex is 3 comma 1. Axis of symmetry, x equals h, so x equals 3. Direction, because it begins with a negative, we know that it is opening down. And to find my zeros, I need to fill in my table. I'm going to use my calculator. First, I'm going to put my vertex right in the middle because my vertex is the middle of my graph. And I'm going to insert it into my calculator to fill in the table around it. So negative 2 x minus 3 squared plus 1. And I'm going to look at my graph. I do cross the x-axis twice, so I'm going to find those when I plot points. If I go to my table, I want to fill it in around 3, 1. That's my vertex. All right, so from 3, 1, I want to fill in the x's to the left and to the right on the graph. So I'm going to have 3, 2, 1, 0, negative 1 for my x's, and going the other way, 4, 5, 6, 7. So when I look at my calculator, I'm going to fill them in. Negative 1 is negative 31, 0, negative 17, 1, negative 7, 2, negative 1, 4, negative 1, 5, negative 7, 6, negative 17, 7, negative 31. So now I am looking for my zeros. On day 2, you saw examples of zeros that weren't whole numbers. Zeros happen right here between where y goes from negative to positive. So it goes from negative 1 to positive 1. That's where it crosses the x-axis. It happens again here, going from 1 to negative 1. So that's where my 2 zeros are going to be, between 2 and 3, and also between 3 and 4. And now I should be able to graph. So my vertex is at 3, 1, and then I can plot the points 2, negative 1, and 1, negative 7. And on the other side, 4, negative 1, and 5, negative 7. And I know that I cross somewhere between 2 and 3 and between 3 and 4. And I'm going to sketch the graph. Connect the dots. I'm going to draw in my axis of symmetry at positive 3. Straight down the middle. And then we have to describe the transformations. Describing the transformations, I'm going to start at the left. I begin with a negative, transformations from the parent function. A negative reflects over the x-axis. A whole number before the parentheses is a vertical stretch. A minus 3 in the parentheses goes the opposite of what you think, so that moved it to the right 3. And plus 1 at the end moves up 1. And those are all of my transformations. The last thing that it asks me to do is to write my equation in standard form. My equation, y equals negative 2 x minus 3 squared plus 1. I always start by squaring the parentheses. What that means is x minus 3 times x minus 3. You can FOIL first, outer, inner, last, or you can box method. Most of you like to box method, so we'll show that also. I make a 2 by 2 box. I have x minus 3 and x minus 3. X times x is x squared. X times minus 3 is minus 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is a positive 9. I have to combine like terms diagonally. And I find out that that part of my equation is x squared minus 6x plus 9. All right, that's this little orange bit. X minus 3 squared is this. Now I have to fill in everything else that was left around it. I had a negative 2 in front of it, and I had a plus 1 at the end. And now I'm doing order of operations. Order of operations tells me to multiply first. So I have to multiply by distributing this negative 2 to all 3 items inside the parentheses. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is a plus 12x. And negative 2 times 9 is minus 18. Then I bring down this plus 1 because I haven't used it yet. And I have to combine like terms here. Negative 18 plus 1. So I have negative 2x squared plus 12x minus 17. And that is my equation in standard form. Thanks for watching.